Okay, let's move to the next section, which is how do we implement the Internet of Things. Okay, so this would show you a basic system architecture of an IoT system. So you have the Internet of Things. For example, over here you have camera, you have maybe an IoT device, a smart faucet, which is for water. You might have Internet of Medical Things, wearable sensors and stuff, smart bulbs and other things. Now, normally the IoT devices, they are very simple and low cost in nature. Okay, so they won't have the full TCP/IP stack in them. So normally what you have to do is you have to connect them to other border routers, I would say, which in turn connect to the internet. So normally you would have a 6 low pan gateway over here. So you can consider these as gateways which are connecting the IoT devices to the internet. Okay, and then you might have some server over here, which is where the data is being uploaded. So when you are doing some experiments or you want to create an IoT device, you can just ignore this puff thing over here. This diagram is from one of my papers, so you can just ignore that. So if you have an IoT device, then you need a gateway. So normally, if this would be an Arduino sensor, okay, and then the gateway can be a Raspberry Pi, which is more powerful than, it is also considered as an IoT device, but it's at least more powerful than the more powerful in the typical sense. So normally when we carry out experiments, we would use a Raspberry Pi as a gateway instead of the IoT device itself. And then the Raspberry Pi can be connected through Wi-Fi to the server or cloud. Okay, so this is how normally you would start off to create an IoT device, and the Arduino over here would be programmed to do different things depending on the sensor or what application you want to do. Okay. So let's look at the a simplified IoT stack. So there might be other way of representing IoT devices with much more layers. But over here, for the sake of simplicity, I just chose this one, which has maybe 1, 2, 3, 4 layers. So it's quite a simplified version. So at the bottom layer, you have communication protocols, which might be Bluetooth Low Energy, BLE, Zigbee, Wi-Fi, or even LoRaWAN in that regard. Then you have the microcontrollers at the hardware abstraction layer. So microcontrollers are very important for IoT devices because those are like the brain of the device. And sitting between the hardware and the microcontroller is the firmware. So it's there. Then at the top you have the operating system or the real-time operating system, and in some cases you might not even have an operating system, and that's what we call bare metal, where you have some code which is directly interacting with the hardware. So now you would find a lot of IoT devices or microcontrollers which are based on Unix. Then you have some real-time operating systems such as the Raspbian, which is used in Raspberry Pis. So in IoT devices, the real-time operating systems are very important because they are normally they can be normally used with simple devices. These become very important. So if anyone is interested in IoT device, you can see that there are multiple things you have to learn. One is the communication layer. Okay, you should know get some information. We'll revisit these things in a moment, but just to give you an idea, then about firmware. What is firmware? How to design firmware? Then microcontrollers, and then operating systems. So you should have some knowledge about operating systems as well. Okay, so when we go to microcontrollers, what are the most common microcontrollers used for IoT? So normally we would go with the Atmel AVRs. Okay, these Atmega series, these are very popular. Then we also have some microcontrollers from Texas Instruments, which are based on ARM, on the ARM Cortex M4, M5, or M8, or, but so normally these ARM processors would be much, much, much powerful than these other ones.